Welcome to GCP Private API Access. Hey everyone. Today we are diving deep into one of the most critical aspects of Google Cloud networking. How to securely access Google APIs from your private virtual machines. This is a real-world problem every GCP engineer faces. You have virtual machines without external IPs for security, but they still need to talk to services like cloud storage, BigQuery, or pub/sub. I will walk you through three distinct approaches, from the basic public method to the advanced private service connect, showing you exactly when and why to use each one. By the end, you will understand the complete DNS flow, security implications, and practical configuration steps for enterprise-grade private connectivity. Let me start by explaining the fundamental problem we're solving here. When you create a VM in GCP without an external IP address, which is the security best practice, that VM cannot reach the internet by default. But here's the catch. Google APIs, like storage.googleapi.com, are accessed via public endpoints on the internet. So how do we bridge this gap? This isn't just a technical challenge, it's a business requirement. Your applications need to store data in cloud storage, query BigQuery, or publish to pub/sub, all while maintaining strict security postures that prohibit direct internet access. The solution involves understanding Google's private network infrastructure and the three different methods they provide to access it securely. Method 1. Public interface, not recommended. The first method is the simplest but least secure, giving your virtual machine an external IP address. I'm showing you this because you need to understand why it's problematic. When you assign an external IP, traffic flows from your virtual machine through the VPC's default internet gateway, over the public internet, to Google's public API's endpoints. Yes, it works, but you're exposing your virtual machine to the entire internet. That means potential attacks, the need for complex firewall rules, and your API traffic traversing public networks even though both endpoints are within Google's infrastructure. This is like sending a letter to your neighbor by mailing it across the country. It works, but it's inefficient and insecure. Let's look at better approaches. Method 2. Private Google Access Overview. Private Google Access, or PGA, is the classic solution that's been around for years. It's a subnet-level feature that allows virtual machines with only internal IPs to reach Google services privately. The key insight here is that PGA works by intercepting traffic. When your virtual machine tries to reach storage.googleapi.com, PGA intercepts that traffic before it goes to the internet and reroutes it through Google's internal network. This gives you security and performance benefits. Your virtual machine stays private, and API calls use Google's high-speed internal infrastructure instead of the public internet. But there's a critical requirement. PGA still needs a default route to the internet gateway in your VPC. It's not truly isolated, it's more like a smart traffic interceptor. Setting up PGA, the network foundation. Let me walk you through setting up PGA step by step. We'll start by creating the basic network infrastructure for a project called Corp Data Project 777. First, we create a custom VPC network. This gives us full control over subnets and routing. Then, we create a subnet in IS-East4 with a /24 CIDR block, which provides 254 usable IP addresses. The key command here is the subnet creation with the specific region. Remember, subnets are regional resources in GCP, so you need to specify the region where your virtual machines will live. Notice we're using custom subnet mode. This is important because you can't enable PGA on legacy networks. You need the flexibility that custom subnets provide. Enabling PGA, the magic switch. Now comes the critical command that enables private Google access. This single command transforms your subnet from requiring external IPs to allowing private access to Google services. The Enable Private IP Google Access flag is what makes the magic happen. Once you run this, any virtual machine in this subnet without an external IP can reach Google APIs. To verify it worked, We describe the subnet and look for private IP Google access true in the output. This confirms the feature is active. Then we test it by creating a virtual machine with the no address flag, which ensures it has no external IP, and curl storage.googleapi.com. If you get a 200 response, PGA is working correctly. Advanced PGA DNS configuration. Here's where PGA gets sophisticated. Google provides two special domains for private access, and understanding the difference is crucial for enterprise deployments. The private.googleapis.com domain resolves to IP range 199.36.153.8/30 and provides access to most Google APIs. But restricted.googleapis.com is more secure. It resolves to 199.36.153.4/30 and enforces VPC service controls. VPC service controls is Google's data exfiltration protection system. By using the restricted domain, you ensure that even if someone compromises your environment, they can't easily extract data from your Google Cloud resources. The DNS configuration involves creating a private zone for googleapis.com and using CNAME records to redirect all star.googleapis.com requests to your chosen restricted domain. PGA DNS setup commands. Let me show you the exact DNS configuration commands for PGA. This is where many engineers get confused, so I'll explain each step carefully. First, we create a private DNS zone for googleapi.com. This zone will only be visible to virtual machines in your VPC network, not to the public internet. Then we create a CNAME record for star.googleapi.com pointing to restricted.googleapi.com. This wildcard means any subdomain like storage.googleapi.com or bigquery.googleapi.com will resolve to the restricted domain. Finally, we create the A record for restricted.googleapi.com itself, pointing to the 4 IP addresses in the restricted range. These IPs are Google's private access points that enforce VPC service controls. Don't forget the firewall rule allowing egress to port 443 on the restricted range. Without this, your API calls will be blocked. Method 3. Private Service Connect Introduction. Now let's talk about Private Service Connect. This is Google's modern, most advanced solution for private API access. PSC represents a fundamental shift in how we think about private connectivity. Unlike PGA, which intercepts traffic, PSC creates an actual private endpoint inside your VPC. This endpoint gets an IP address from your own subnet and acts as a dedicated gateway to Google APIs. The beauty of PSC is complete isolation. It works even in VPCs with no internet gateway or default routes. Your virtual machine can be completely air-gapped from the internet while still accessing Google services. PSC also provides granular control. You can create different endpoints for different API bundles, implement custom firewall rules, and even use your own DNS names for better organization. PSC Architecture Deep Dive. This diagram shows the complete PSC architecture. I want you to notice several key components that make PSC special. First, the virtual machine and PSC endpoint live in the same subnet. This means traffic between them never leaves your VPC. The PSC endpoint acts like a local proxy for Google APIs. Second, notice the dual DNS architecture. Google automatically creates a p.googleapi.com zone with endpoint-specific records. But you manually create a googleapi.com zone for standard API names. This dual approach gives you flexibility. Applications that can be configured use the automatic p.googleapi.com records. Meanwhile, legacy applications use standard names that get redirected through your manual DNS configuration. The orange styling indicates this is the most secure and modern approach for private API connectivity. PSCDNS. The partial automation story. Here's the crucial point about PSCDNS that often confuses people. It's partially automatic. Let me explain exactly what Google does for you and what you need to configure manually. When you create a PSC endpoint, Google automatically creates a service directory DNS zone for p.googleapi.com and generates endpoint-specific records like storage-endpoint name.p.googleapi.com. But most applications expect standard names like storage.googleapi.com. To support this, you need to manually create a googleapi.com zone with a wildcard CNAME record. The wildcard star.googleapi.com is a real DNS feature that matches any subdomain. It points to an A record for googleapi.com that resolves to your PSC endpoint IP. This setup allows both approaches to coexist. Modern applications can use the automatic records, while legacy applications work unchanged with standard API names. Setting up PSC. Prerequisites. Before creating PSC endpoints, you need to enable 3 specific APIs. This is more than PGA requires because PSC integrates with Google's service directory for automatic service discovery. The Compute Engine API is obvious. You need this for creating the forwarding rules that act as PSC endpoints. The Service Directory API enables automatic endpoint registration and service discovery features. Cloud DNS API is required because PSC automatically creates DNS zones and records. Even though it's automatic, PSC still uses the Cloud DNS service under the hood. These prerequisites highlight that PSC is a more sophisticated system than PGA. It's not just network routing, it's a complete service connectivity platform with DNS integration and service discovery. Creating the PSC endpoint. Now let's create the actual PSC endpoint. I want you to understand what each command does because this is where the magic happens. First, we reserve a specific IP address in our subnet for the PSC endpoint. Using 10.50.10.100 makes it easy to remember and creates a predictable network architecture. The key command is creating the forwarding rule with target Google APIs bundle equals all APIs. This creates a forwarding rule that acts as your private gateway to Google APIs. When you run this command, several things happen automatically. Google creates a service directory namespace, registers your endpoint as a service, and creates the p.googleapi.com DNS zone with endpoint-specific records. The endpoint immediately becomes available at 10.50.10.100, and you can start sending API traffic to it instead of public Google endpoints. Manual DNS configuration for standard names. Here is the manual DNS configuration that makes PSC work seamlessly with existing applications. This is the part that Google does not do automatically, but it is crucial for real-world deployments. We create a private DNS zone for googleapi.com. This will handle all the standard API endpoint names that applications expect to use. The A record for googleapi.com points directly to our PSC endpoint IP. This is the target that all API calls will ultimately resolve to. The wildcard CNAME star.googleapi.com is the brilliant part. It catches any subdomain, for example, storage.googleapi.com, BigQuery.googleapi.com, Compute.googleapi.com, and redirects them all to the googleapi.com record. This DNS resolution flow means applications can use standard endpoint names without any configuration changes, while traffic flows privately through your PSC endpoint. DNS resolution flow explained. Let me walk you through exactly what happens when an application calls storage.googleapi.com with PSC configured. Understanding this flow is crucial for troubleshooting. The application makes a standard API call, no special configuration needed. The DNS resolver starts by checking for a match to storage.googleapi.com. It finds the wildcard CNAME, star.googleapi.com, which matches. This CNAME points to googleapi.com, so the resolver now needs to look up that A record. The A record for googleapi.com returns 10.50.10.100, your PSC endpoint's private IP. The application now sends its HTTPS request to this private IP instead of a public Google IP. The PSC endpoint receives the request and forwards it through Google's private network to the appropriate API service. The response travels back the same private path. The beauty is that the application is completely unaware it's using a private endpoint. The DNS configuration makes it transparent. Testing PSC connectivity. Testing is crucial to verify your PSC setup works correctly. I'll show you the specific commands to validate both DNS resolution and API connectivity. First, create a test VM in the same VPC without an external IP. This proves that PSC works in isolated environments where PGA would fail. Use NSLookup to verify that storage.googleapi.com resolves to your PSC endpoint IP 10.50.10.100. If it resolves to a public IP, your DNS configuration has issues. Test the automatic p.googleapi.com records too. These should resolve to the same PSC endpoint but with endpoint-specific names like storagefr for Google APIs.p.googleapi.com. Finally, use curl to make actual APIs. A 200 response means PSC is working correctly. Any other response indicates firewall, routing, or authentication issues that need investigation. Comparing the three methods. Now let's compare all three methods side by side so you can choose the right approach for your specific requirements. Each method has distinct advantages and limitations. The public interface requires external IPs and uses the least secure path, but it's simple to set up. PGA eliminates external IPs and uses private paths, but still requires internet routes. PSC provides the highest security with no internet route dependency, automatic DNS integration, and complete isolation capabilities. It's the most modern approach but requires more initial setup. Notice the DNS management differences. PSC provides automatic zone creation while PGA requires manual configuration of everything. For new deployments, I always recommend PSC for existing environments with PGA. Consider migration when you need enhanced isolation or granular control. PGA versus PSC architecture comparison. This three-panel comparison really highlights the fundamental architectural differences between PGA and PSC approaches. On the left, PGA still depends on a default internet route. It works by intercepting traffic that would normally go to the internet. This creates a security dependency that enterprise environments often want to eliminate. The middle panel shows PSC in a standard configuration. Direct DNS resolution to a private endpoint without any internet route dependency. This is already more secure than PGA. The right panel shows PSC's ultimate capability, complete isolation. The virtual machine has no external IP and no default route to the internet. This is impossible with PGA but works perfectly with PSC. This isolated configuration is ideal for highly regulated industries, sensitive workloads, or any environment where zero internet connectivity is a hard requirement. Extending PSC to on-premises. One of PSC's most powerful features is hybrid integration, extending private Google API access to your on-premises networks. This diagram shows the complete architecture for hybrid PSC connectivity. The key components are the cloud router that advertises your PSC endpoint routes over VPN or interconnect, and the cloud DNS inbound forwarding policy that handles DNS queries from on-premises. Your on-premises DNS server forwards googleapis.com queries through the VPN tunnel to Google Cloud DNS, which resolves them using your private zones and returns the PSC endpoint IP. Then API calls flow from on-premises to the PSC endpoint IP over the same VPN tunnel, providing completely private connectivity for hybrid workloads. This architecture eliminates the need for on-premises systems to reach Google APIs over the Internet, improving security, performance, and cost optimization for hybrid environments. Service Directory Integration. Let me explain the sophisticated automation that happens behind the scenes when you create a PSC endpoint. This service directory integration is what makes PSC so powerful for enterprise environments. The solid green arrows show what Google does automatically: creating namespaces, registering services and endpoints, and generating DNS zones. This happens without any effort from you. The dashed purple arrows show the manual DNS configuration you add for standard API compatibility. Both systems work together seamlessly. Service Directory provides centralized service discovery, automatic DNS updates when endpoints change, and integration with monitoring and management tools. This integration means PSC isn't just a networking solution. It's a complete service connectivity platform that scales across regions, VPCs, and even projects within your organization. Best practices and recommendations. Let me wrap up with practical guidance on when to use each method and key security considerations for production deployments. For new projects, start with PSC. It provides the best security, performance, and future-proofing. For existing PGA deployments, plan migration to PSC when you need enhanced isolation or granular control. Always use the restricted domain with PGA for VPC service controls. Implement least privilege firewall rules regardless of which method you choose. Monitor and audit API access through cloud logging, and consider PSC for any sensitive workloads requiring complete network isolation. The migration path from PGA to PSC is straightforward, and PSC's automatic DNS configuration eliminates many of the manual steps that make PGA complex to manage at scale.